All right. Okay. How's everyone doing today? Welcome to my stream. I'm pretty excited about this one because I'm going to get to finally show off some of the stuff I've been working on for months. I mean, to be fair, we've been covering it in the stream. If you've come in and watched pieces of the stream over the last, I want to say, especially since like October, but like since, you know, we've been even talking about these theoretically like with my hack MDs going back into the summer, right? I'm trying to think of course, everything's out, not signed in right now for me, but yeah, I don't know. We'll give everyone a couple minutes to join on. Probably also post on Blue Sky that we're live. Second. We'll talk about this later. Sorry, I just can't. I don't want to tear into React too much. We have too much important stuff, but maybe if we have some time at the end, we can talk about it. All right, actually, you know what? I want to quote tweet the other one. Here it is. Sorry. Should open that too. Sorry, I wanted to start this stream on time, so much so that I actually like just jumped right in, practically not even ready, just because as I said, very, very excited about this. All right. Good. All right. Cool. How's everyone doing? Everybody saying hi in the chat? Good. Hello. No, I have not started at all. I think I just said like an okay, all right, kind of talking to myself that might have come in before the stream talked. I was also adjusting the volume on my mic, so that might have been it. Hello. Hey, Greg, how's it going? Hi. Yeah, I'm sorry. It's Valentine's Day evening too. If I was streaming at night, I wouldn't be doing it tonight. But unfortunately, where some of you are, it is evening. So yeah, I apologize for that. But this one's going to be a good one. And if you're here, God, there's too many highs to keep track of. If you're here, then you can ask the right questions and see where this goes. Yeah, Dev is a happy person today. He's been very helpful. You know, it's always good to get feedback on stuff, and he's been right there testing out and finding bugs in my stuff almost immediately. That's the hardest thing when you're working on new things. You make things and you like think it works a certain way, and then you find that there's like a bug, and you don't intend it, but the other person assumes that it's intended, and they're just like, "Oh, interesting, works this way," blah blah, and they kind of go off on that tangent, and then you're like, "Oh crap, that wasn't the way it's supposed to work." Anyways, we got what 200 plus people already in here, so I think we can probably get started. Twitch is a little bit weak today, but you know, great place to watch on as well as YouTube. You know, send those hearts, those likes. They'll help the video later. As you know, I don't always post videos. I did post my very first video last week when I clipped out a section. I was thinking of doing this as a video, and then I'm like, oh man, I'd have to do so much prep and it won't. Yeah, I think some of the stuff I'll be showing today might be so crazy people won't understand what they're seeing at first. So I'd much rather have the chat help ask the right questions. We're not at the like conference talk level, you know, raise the signal out of the component, local state, global state point of this demo yet. All right. So where should I start? Maybe I should just start here. This is funny. This example is the least interesting thing we're probably going to do today. This is like the easy part, the part I did like 5 months ago. But it's going to show something that I think will immediately put us in a different world, and then we'll kind of build up the solution from the beginning. I want to talk about several topics today. Async's the most obvious one, but I do want to talk about the idea of how push-pull can actually change your perception of how things execute. Like, I feel like a lot of frameworks have what I call granular pull, or sorry, coarse-grained pull, like React. And then people are just getting used to now about the push aspect of signals, where you're just like, oh, only this piece updates. But we can leverage the push-pull uniquely, and that's going to be a big part of these solutions. And then I also want to talk about some new types of reactivity. I did a stream a while ago on mutable, like derived stores, like mutable reactivity, and it was based on an article I wrote, which was fine. It showed like a concept, but the problem was it wasn't a very safe implementation. It was kind of like a, hack it together and it kind of works. Well, I figured out how to make the safe implementation and make it performant, which is actually very ironic because there was just a bunch of conversation recently. Vue Vapor, I think Evan was showing off some performance, and he's like, oh, we don't use crate selector. It seems like a specific kind of hack. And the thing is, we figured out how to generalize the crate selector problem. So it's not a hack. I agree. The original one was kind of like very specific use case, but I think it's actually a general problem in reactivity, and I found a performant and correct way of doing it. So I want to talk about how that works as well. So we're going to see all the aspects of it. Basically, we're going to use Solid Experimental 2.0 as an example. There's lots of bugs in it still, but I've implemented all the client-side features at the core level, other than transitions or transactions, whatever you want to call them, the new version of that. So we'll be able to use that directly when looking at error handling and suspense and all that stuff. Just, we haven't done transitions. Transitions are still part of the equation here. I don't think we can get rid of them. But everything up to that point is a whole nother world. So I'm very excited about talking about this stuff today. So you're saying it's ready for prod. No, I'm not. And I've actually released an announcement about the state of Solid 2.0, which we can look at later in this week in JavaScript. Okay, so yeah, no, what's really interesting about this is the mechanisms that I'm going to use today are completely runtime. You don't need a special compiler. People will build compiler stuff based on these mechanisms, I'm sure. What's really cool is that what we're going to be looking at today is fundamental to a level that, in theory, any signals implementation could look at doing. It also highlights the importance of scheduling and why, say, something like crate effect isn't in the base implementation. I've been doing a lot of work trying to still figure out how these primitives work, but let's start with the results and roll backwards, right? So let's start. I'm going to open up an example that I shared on Twitter earlier today. And I think some people should be familiar with this example. And this is a very basic look at it, but the idea here is I've created a suspense component. And for those who don't know what suspense is, the idea is like when something below is not ready, we're just going to show some fallback. You can see this when I press refresh. There's a loading here for the 2 seconds that this is loading. And then we're going to show the content. Now, different frameworks have different ways of implementing this, right? Right. And yes, there's 2 places that, there are going to be a number of breaking changes, but I think there's 2, and I'll go over them today, that I think will be very noticeable to the developers. They're the ones that will catch them off guard. So I will talk about those today and why we got there. But the key part, I'm hoping that I'll convince you that they're completely necessary and that it's worthwhile. So we'll get there. But first, we see this mechanism. Suspense, I have a few components of the same component. I just pass a name. You can pretend it's like an ID or something. It's something that defined a unique characteristic of the component. And then what I've done here in this component, this is just garbage for metrics, is I've created async, which is calling fetch delay. And the fetch delay is basically a promise. You can pretend it's a fetch request, and it sets a timeout for the time you give it for 2 seconds, and then it just sends the date, the current timestamp, as the result. And then I'm rendering the name of the component. I'm rendering some count, which is literally just like I could have put console log here, but I wanted to visualize it. It's just something that only gets incremented when the component body gets rendered. I put up, I'm formatting the timestamp. So I'm removing this offset, which is the time now. So you can basically set time now as 0 instead of, whatever the current Unix timestamp is. And I'm formatting both the time start that we get here and the time that we get resolved from A. And as you can imagine, what happens here is I'm going to refresh it. We're going to see loading while it's loading. And then what we're going to see is that each of A, B, or C rendered once, they started at time 0 or 0.0001. You can see it's basically at 0 seconds. And they all took 2 seconds to fetch because they all take 2 seconds to fetch. Basically, they all fetch in parallel. Right? But before we move on, I want to just point a couple interesting parts of this example so you can kind of start thinking about like, hey, there's already something not quite normal going on here. I'm hoping everyone can see the text in here clearly enough. So the first thing that we're going to notice that's kind of interesting is that format takes a time number and then it subtracts some time minus offset, divide by 1,000, and returns it, right? And I mean, just for fun, have you ever, like, what happens if you do undefined -1? You get not a number. How if you do undefined -1 divided by 1,000? It's still not a number. So at least it doesn't error. I'll give you that much. So the fact that it doesn't error doesn't actually prove the point that I was thinking of showing here. But the question you might have here is, if we console log time, will it ever not be a number? Right? Let's refresh this. There's no hot level HMR in this demo. I'm literally just using rollup raw. I haven't even got around to making a Veep plugin work yet. But let's see what happens. No, time. Oh, yeah, that's funny. Try her. Yeah. It's because there's 6 calls. Each component calls it twice. So you saw the first 3 calls and then you saw the second 3 calls come in. If you notice, time is never undefined. What happens is the first set of calls, which happen, synchronously when we call start time, happen first, and then the second time only these ones happen. This gives you a hint into the fact that the component only renders once. So if we watch it one more time, first time the components and this, and we can actually get. Yeah, I don't want to change the API too much, but I think you can follow what's going on here. Essentially, the first time format gets called is when it gets called in the static time, and then the second time it gets called is when this resolves. So how does that even work? Well, let's look at this new primitive. And to some of you, it's not that new because we introduced this in Solid router in 1.0 time period, a very similar primitive. But this is now a core primitive coming directly from Solid.js called createAsync. And in this thing, if you look at the signature here, it expects it's a computation, sends in the previous value, and then expects a promise of a number, an async iterable of a number, or a number back. And what does it return? Accessor of a number. So if we look at A is an accessor number. For anyone who doesn't know what an accessor is in a Solid, it's just a function call that returns a number. This means that A never returns undefined, which is why we never saw undefined in here. That's why A will only ever return numbers. So all those like null checks, like is it there? Is it ready? You know, and that kind of, is it ready is still a fair question, but the question of is it there, like, is no longer a question here. A promises that when you access it, it will give you the resolved async value. Oh, it will throw then. Exactly. See, people don't always get my subtweets. What you're gonna see is, and this is like the second time I've done this, you know, like categorically, is React having really good ideas, yet being very, very limited by their component model. Like basically, React has exceptionally good theoretical ideas in terms of being able to handle problems in a correct way. It's just that the thing you can do with React are so limited. So yes, we're throwing promises. I know. What does fetching have to do with signals? Well, you have to keep on watching this. See, signals have been synchronous so far, right? And I'm going to get back, we'll get to the basics and see what the tie-in. A is a signal, right? It is an async signal, but it is still a signal. If I turn this into just a signal, it's the same API where I read it. Okay, what do I have to, what do you have for me, Dev? All right. Yeah, we'll get there, Dev. It's a little bit early for that. I get where you're getting. I'll keep that one open in the background. So, okay. It is an async signal, and it's fetching in parallel because it doesn't throw where it fetches, it throws where it reads. This throws right here. When I accessed A, it threw, and it doesn't throw up the whole tree. I mean, I wonder if I can show the compiled output here. I probably can't I? You can see where it throws if I can just pull out the, this is obviously easier in Solid's Playground, but if I'm trying to remember where they put it in here in StackBlitz, it's been a while. It's got the weird name. It's like GitHub exec dist source dist main. Lovely. Okay. So let's get down to the bottom of the file and look at what our JSX compiled to. I mean, you can see it. Inside our component, we have 4 separate insert expressions, right? So where does A read throw? It just throws up to this insert effect, essentially. This is an internal API. It has a create effect, render effect underneath, but it basically just throws up to here. So everything parallel doesn't need to throw. In fact, it just sits there like normal. And then when it's done, we only need to rerun just this one thing. It's the exact same thing that we do when we show people how signals work in rendering in Solid. You know, there's the one effect. You know, you add all the components, you add all the things, and you update the signal, and press the button on the counter, and just the one effect updates. Well, why can't that be the same for async, right? So we don't have to throw away our render tree just because we have something async, right? That would be silly. No, what we want to do is control where it, and we can know when it throws, when it catches, you know, hey, this effect errored out. You can't show the fallback until this effect succeeds. And I'm going to talk about the mechanics of this because it's very related to error boundaries and self-healing that we're going to cover in a bit. But mechanically you can picture it. You create something async, it becomes a signal, and then somewhere else you read it, and it's there that it throws. Which means that everything around it is perfectly safe to go, which is why all of these parallel things are actually perfectly fine, because they are not related to each other, right? Because you get in here, you render this, something in here throws and catches, you render the next one, something in there throws and catches, and there something throws and catches. And it doesn't take it's like not too hard to picture that nesting it doesn't change that behavior. Yeah, yeah. The event handlers are a consideration, but we'll talk about that because I've also considered this a bit, because there there's some stuff here. Two questions. What about async await? Will the type be accessor promise number? No, async await is still returning a promise. So if we go back into our parallel fetching example, I mean, you think you could get it right from the types. Like, I mean, I could do this. I think this isn't going to change the type, I don't think. Why is it being weird? Did I screw up oh, I put on the wrong spot here. Async. I mean, fetch delay is still the same type. It's time promise number. So this is still accessor number. So you can make this async wait. You could put it in here too if you really wanted to, for the same reason, because if you look at it, it expects a promise of a number, an async iterable of a number or number. This is important because this lets us support things like readable streams and whatnot. But I don't know if I need the demo of that right now. I mean, this implementation is completely at the reactive level. So how much effort is for something like this installed? I mean, they could build their reactivity rendering system in a similar way. They could use their compiler to do some stuff. I don't know. Like, it's definitely doable. That's why I'm talking about it here in a general sense. Maybe people won't like throwing, I don't know. Okay. Async starts when created. And we're gonna talk about that in a little bit. I'm gonna get to that. But the idea here is if you wait till read, you can cause the diamond problem again. So generally I'm on the position of that it should fetch eagerly or scheduled, and that it should basically maximize parallelism without causing overfetching, which we'll do some nice scala draws in a bit to show what I mean by that. Okay, sorry, there was two questions there, right? What about async await and the types? Yeah, I think we covered that. Okay, let's continue. The async part isn't actually too complicated. It's the way that I've handled suspense and error boundaries that's interesting. Like they have to be concepts at a reactive level. I mean, they're built from other primitives. Okay, so let's just get rid of that. All right, okay, let's go to our nested example, because our nested example is almost the same, except we have suspense, anchor, or so not anchor, it's funny, I'm so used to capital A being anchor. Suspense component A, and then each of these components, I kind of duplicated them, are basically the same as the old component where we're still doing that count catcher, and then we're like putting we're showing the same content and then we're showing B beside it. And then we're showing the same content and showing C beside it. So basically each component fetches its own data and shows its own data nested. So like, as I said, A calls B, B calls C. So they're not parallel anymore. This one's doing, they're all fetching in their own component. Like A fetches for A, B fetches for B, and C fetches for C, and they're all direct descendants of each other. So the interesting thing about this example, as you guys have probably seen already from the results, is it's loading for our 2 seconds, and then it's the exact same as if we parallel fetch them, because from our perspective, these are parallel fetched, because as you know, in Solid, components are an illusion, right? We don't, again, we're not restricted by a component model. So, you know, as long as you're not saying like render C if B, like as long as you're not directly stacking the dependencies of them, so like B depends on C somehow, or sorry, C depends on B or B depends on A, there's nothing to prevent these from all just going in parallel, because, well, they are parallel. This is only needed in this one effect, and this is way over here. It has nothing to do with that. So now some people are like, oh, well, did we just do it? Did we solve waterfalls? Yeah, because components do not throw out. Yeah. I mean, I've been trying to emphasize this forever. It's funny because React makes such a strong thing about, like, you know, with our smart compiler, you know, we can do all this automation and we don't need signals, these are under hood implementation details. The problem is they're limited semantically. Like the actual design of their language prevents them from doing some of the stuff I'm going to show you today. It's not like we can fix this with a compiler. It's just not how the model works, even from a language level stuff perspective. So, I mean, some of these things they could probably kind of do, but as you watch through, we're going to get to a few examples where it's like you have to acknowledge that there's reactive variables, that there are something like signals, that your data is reactive. Otherwise, it's a re-render model makes no sense semantically. And it wasn't until I started getting to this async stuff that I realized that there were potentially real cases, you know. It's been very exciting, as you can tell, because when I started working in Solid in 2016-17 time period, I was just like trying to prove that we could do what React did, that this model could do everything that React can do. This time around, I'm excited because it's like I get to focus on like what can we do beyond what React can do, right? And I think we're going to see a lot of it today. As I said, this is probably the least interesting example that I'm going to show today. Await is pure overhead. Well, I mean, we'll talk about composition in a minute. Yeah, why would props props children, like why would a prop? Yeah. So like, it's interesting. What I wanted to get to before I kind of went on that tangent is we haven't completely solved client-side waterfalls. Because obviously some waterfalls are unavoidable, A, and B, client has a secondary mechanism that gets in our way here, and that is code splitting. So it is quite possible that you do not want to load all the pages in your app ahead of time. So it would make a lot of sense to code split, and code split will require you to fetch in the main chunk, because otherwise you have to wait for that code to load to do the fetching. It's an inherent waterfall when we split the code. So that is beyond the scope of here. This is why I'm still a big fan of routers, level hoisting, stuff that we do obviously in Solid Router, and the patterns that we've taken there and moved into TanStack Router. Like there is a reason why those things exist still, even in this model, mostly for code splitting though. From a pure, like, I am just like rendering components and component composition standpoint, if you don't put an await in the middle of your component, then you don't have to be blocking. Do you know what I mean? Like, this is the craziest thing when I saw the server component design and they had async components with a wait in the middle. I'm just like, this is literally the last thing I would ever want to do, because you're like saying like await blank. Like, what else are you going to do? It's the same reason why React uses use in the client, because they know that await in the middle of your component is a terrible thing when you have different updates coming in from different places. But obviously RSCs are in a special zone because they don't have client-side updates and state updates. So it's safe enough. In a sense, you almost want generators on the server. I'll get into that another time. But like, I get why they went with that API. But conceptually, I think people should be realizing that async await is the last thing they want. I know everyone's like, oh, but it makes my code all logical and synchronous. Well, do you know what logical imperative code like that is? Well, I just said it. It's imperative. We're using declarative frameworks, places where we have declarative views, declarative data relationships. Async await sets up your code to be back to being imperative again. It's like an anti-pattern. So like, you don't want that in your framework code. You can put it out here somewhere. You have a logical order of operations, but your framework is declarative. Async await and components are not friends. Okay. Make solid.js or check out our native script and Tori streams that I did. Oh God, it's been a while. Was it? I feel like it wasn't just last fall. It was like a year ago fall, wasn't it? Anyway, there are native options. I am obviously, we don't have I forget how big the team is at Meta that works on React Native. It's huge. We don't have, several dozen people working on this problem. But I think solutions in the open source area are getting a lot better. Okay. Yeah. Okay. So this is like getting thrown in the deep end. I think we should step back a moment from these examples and kind of like get back to the fundamentals. So before I do that, this is clear. You understand how parallel and nested fetching is essentially the same thing. So where do I put async fetch? I got something very nice for you. It's right here. It's in create async. Put your async fetch in here, or call it in here. This is your async fetch. There's this beautiful thing called create async. And unlike an effect, which does this write thing, it's derived and non-nullable. It will just, if your async thing was, I don't know if I can force this, but let's say of type user, you get a user, right? Sorry, let's see if I'll do it at the promise level. A promise of user means an accessor of user. Is what I'm getting at. Okay. Yeah. I'm gonna have to mechanically show you that in a bit, but the gist of it is each of those effects are part of a queue that runs. The core scheduling here in a reactive system. Yeah, maybe it's Excalidraw time a little bit before I even get into this. Is there's three pieces of the system, right? There's signals, which I will draw here like this. And then we'll use the diamonds, which are computeds or memos. So let's do this. So signal, let's use a larger font. Signal. I'm going to call it a memo. It's a terrible name. I did steal that from React. It makes sense actually in a push-pull system more, and the way I'm going to talk about it lazily is going to make sense. And then we have a third piece, which I'm going to call effects, okay? 3 shapes, okay? This is not like the Squid Game shapes, but okay. Effect, all right. 3 shapes. Now, what happens in a general and reactive library is you interface with these. Only these have the ability to write. You can write. All writing comes in through the signals, right? Don't worry, we'll talk about errors as well. So only writes come in through the signals. And then when signals get updated, they kind of, I'm going to use this as a dotted line here. They kind of tell the memos and any effect that I might have subscribed to the read. I mean, it could also be directly in the signal, but they kind of notify down. And then there's a smart heuristic of deciding what needs to rerun on the way up. I have a whole stream about this with Milo. You can check it out in the future. But the idea is then the effects, sorry, where's the dotted line? Bring it back. Then the effects end up going, oh, hey, have you updated? And it checks and it goes, oh, actually, I don't know. I need to check this one. Well, in this case, it knows the signal has updated. You know, it doesn't actually have to go up because the signal can tell it when it does the initial write that it's changed. So, but you can picture that it just kind of goes up the chain that asks this question. The point is, this notifies and puts these in a queue, and it puts them in like this stack that needs to know later to go pull them all down. So even though this notifies at first, this goes in a list, and this list you run through all the effects. So if an effect fails while it's running in that list, what I'm doing essentially is using context, more or less. I'm basically saying like every effect under this suspense boundary, because we have this concept of ownership in Solid, where this idea of like context is this idea that any reactive thing built under another reactive thing is owned by the parent. So when the parent reruns, it disposes of the children. Our trees are actually just like almost like effects and effects and effects and effects. So what ends up happening here is we have this queue and it's owned by somewhere above in context is suspense boundary. If this fails, we're just like, okay, keep note of that. We'll need to run it later. And we just like tell that thing like, hey, look, more than one thing. I literally keep it in a set. It has failed. Switch the toggle signal on that control flow to show the fallback. And then later on, when it resolves or, you know, and it's able to remove itself, maybe it gets cleaned up for some reason. It does the same thing and it goes, oh, hey, I removed myself. There's nothing left. Flip that toggle. That's the core mechanism. The throwing is localized to the effect, and then the queue on each granular level can decide, you know, be kept track of from a suspense standpoint. Yes, memo is the same as derived and spelled. Yes. Again, errors, you could try catch inside your create async if you wanted to, but generally errors are handled where they're read, not where they're fetched, because we care about where in the UI we can't get it. And in theory, non-async things can error as well. You can have a memo error. And again, it's not the memo's responsibility to tell the error boundary, it's the effect that reads it, because that's the part of the UI that can't render because of the error. We've inverted the whole thing around. Okay, so I'm hoping. Is it literally implement try catch? Yeah. I mean, I mean, I can show this really quickly. And I think I'm not going to dwell on this, but anyone who wants to see the implementation of what I'm doing, it's all on this main branch in the Solid Signals repo. I'll drop it here for you, for all the techie people out there. But to answer your question in a very simple way that other people will understand, if I find the update function in here, what you're going to see, there's update, track, update. You're going to see this try, dispose the previous cleanup, run the thing. If it succeeds, write the new value. Otherwise, if error, instance of not ready, error, write an unchanged value and set some flags on it. Otherwise, if it's some other kind of error, handle the error on the node. This is the generic computation that everything else derives from. So at its very core, it is just a try catch. There's more to it, but yes. Right. Yeah, I'm hoping, yeah, yeah, so where was I? I was in Excalibur. Okay, so at the very base level, our mechanism is about pushing everything down to effects that get scheduled, essentially. Okay, so what I'm going to do here is I'm going to fork this parallel fetching one, and I'm just going to call it like playground. And we're going to build some basic stuff here. I forked the parallel one because it's simpler. We can get rid of multiple components. We can just have our one component. And now we can play. I'm going to get rid of most of this extra garbage. Count. Let's just put A in here. Does this work? And there's our timestamp without any formatting. Okay. Maybe we'll set our fetch at 1 second. Okay, cool. So now we're set up to play. Okay. So yeah, I mean, I've kind of hinted at this already, and instead of time now, because I did the whole time thing because I was trying to like show the parallelness. Let's just do something silly where we just, whatever value we pass to this. So yeah, let's do value t, I guess. And then we will resolve value. This is just the most generic thing I can think of doing. And that way, when we say something like hello in 1 second, we should get hello in 1 second. And when we look at our types, create async, we get a accessor number. Why does it think we get accessor number? Because I told it was a number. Let's tell it it's a t. Okay. We get accessor string. Okay, there we go. Ta-da. Yes, the package is right here. You could technically use it today. It's changing still fairly rapidly, but it is a separate package. It's published on npm at solid.js/signals. All right, so now let's talk about some characteristics here of our async here, because we'll just let's just leave there. Okay, let's talk about some characteristics of our async. So first of all, we can derive from it. So let's go upper. You know, this is always my favorite. Create memo a dot to uppercase. And we know this works. Hopefully upper. And we got capital thing. And again, if you think about it, this one I know for sure, but if we went into the console and said undefined to uppercase, we're going to get a type error. So this is non-nullable suddenly, which this is just a nice blessing. You know how much everyone gets annoyed at signals and ternary stuff? This reduces that narrowing problem significantly. But yeah, so here we go. It derives. But I think the part that might be more shocking to React developers is that which one of these suspense fallbacks will trigger here, right? Let's format. Let's save this. Format, yeah. Which one of these suspense fallbacks will trigger? Question for you all in the chat. What would React do? Well, first of all, React can't do this because in React you can't. I mean, you can technically fetch above the suspense boundary, but then you're gonna have to use in here. So the suspense has to be in a separate component. You can't just like go, oh, I'm gonna fetch some stuff and then suspend it down here. Good. I think the chat knows what's up. Yeah, it's because everything happens on read. Loading 2. Yeah, so we don't need loading 1 anymore, okay? Solid 1 works like this too, except for Solid 1 has this terrible problem where upper actually triggers the suspense boundary because this is actually owned by here, and memos participate in part of this kind of boundary graph, whereas in 2.0, memos do not participate, only effects. So it's just this one effect in the div, and sure enough, this becomes our loading state. Okay, so, okay. Yeah, suspense while creating new components. Okay, so, oh, actually, good question. What happens if I don't put suspense in here? I'm undecided what I want to do, to be fair, but from a technical standpoint, I don't need to do anything. Right? I mean, if there's no suspense to notify to do the fallback for, we can just not. I like, yeah, I mean, it's tricky, right? Because this is what I call unpredictable tearing. I have somewhat of a solve for unpredictable tearing, but the problem with unpredictable tearing is the intersection of async stuff with non-async stuff, right? What I mean by that is, if I had, let's pretend now that I have a signal, okay, const, it's funny. What I'm gonna, it's like backwards, whatever. Name equals create. Actually, I need the, you know how we do here. Name equals create signal Joe, whatever, right? And then if I was, I mean, obviously I can just stick it out here, right? And then when I refresh, you're going to see, hopefully, something work properly. What am I missing an import? Haha, create signal. Right, you see, this works kind of oddly, but it works. But if I do this, now they're entwined. So Joe doesn't show up until hello shows up. It's intuitive, but it's also like it's I don't think it's good. I'm going to do this. I don't think it's good that, I mean, this is initial showing, but what if name was 1 or was one name and then we change it to another name? Are we going to end up in a scenario? I mean, I can do it right now. I'll show you what I'm talking about. I can do it right now. We can add a button. on click set name John. Set name. Right? Oh, sorry. Click. Watch what happens. Oh, right, because I fixed this already. Huh. Oh, right. Huh, never mind. I can't show you because I already changed this. You might be wondering how this would work. I got ahead of myself here. Did you what I was expecting to happen, what you should have expected to happen from what I showed you so far, is that hi, hello, Joe would still show when I clicked up, and this would update to John, and then this would update to John when the async came in. I was thinking that it would like you would see Joe in two different states. Wait, so does A return or does it throw? This is where things are going to get interesting in a minute, because the answer is A never returns undefined, but sometimes A doesn't throw. So yeah, I see the difference here is you, as I was trying to get at, is you kind of want suspense, which is why I've been tempted to not allow this behavior. But you kind of want suspense here so that you can handle, you know, the weird jumping in and out. Now it's just loading and it's ready. You know what I mean? Now, the thing is, I was already kind of getting into this. We have multiple options on how to handle things when they update. And the way that we typically do this in Suspense, and the way I even first implemented this, is that when I click this button, you expect this whole thing to unmount and like render again. And that's the right question for consistency. But I've been working on something, and if you remember some of my HackMDs here, my notes, I've been working on something for ages. God, I can't even go back far enough. Nature of async, further. No. Oh, where is it? No, is it further than this? No, not further than that. Run once suspense. Yeah, 8 months ago was the last time I changed this, and this was a running document. It was this idea that is it possible that we don't always just go to fallback when we update? So I'm going to show you what happens when we do this here. Look, it's loading, but then when I click on it, it didn't unmount itself. What happens if I console log in a component? Depends where you like what component. It will read it and go up to the nearest suspense boundary that the component's called in. I don't recommend doing this. As you know, in solid, console logging top level is basically pointless. No one does that. Like, in fact, if I go in here and look at our playground and I go, ooh, I want to know what count is, and I go console.log count. First of all, ESLint's going to be like, don't do that. Second of all, you see that one? It's never going to update because the component doesn't run again. So technically, yes, it will throw, but also technically you should never ever do this. Because it literally does nothing. Do you know what I mean? Okay. Yeah, I don't know if I should be jumping into this run once thing just yet. Because fundamentally, yeah, no, I understand. But very quickly you will understand that it doesn't work. So it's not so much a problem when the model literally doesn't work. The thing is, internally in the reactive system, I just showed you how this is opt-in tearing. And that's weird. I actually had to add this because internally in the reactive system, we actually want, for consistency's sake, to always throw. See, here you can tell the only reason that this is possible, where Joe can update independently of this, of an, like, where is it? I guess I have to, technically I have to, sorry, this is my bad. Technically I have to trigger this as well. Sorry. The only way that this can trigger up, like, I'm trying to think of a better way to do this. Plus, maybe plus name dot first, I don't know, name 0, like just get the first letter. I just need something to show that it's different after we do it, right? It's gonna be hello J, and then it's gonna be, oh no, the first letter is the same. Set name Ron. Okay. Okay. See how it goes to Ron first before the R goes to J? The only way we're able to do that in the middle of this expression is if when it updates the second time, it actually gets the previous value instead of the throwing, right? That's the only way that this is possible. So like the problem is, if this relationship, I'm showing you the exception case first when I should show you the base case, right? Which is the problem. Let's basically create, I'm trying to think of how we want to create this. I'm gonna create an effect. Now, this is going to be probably the most controversial thing that I do on stream for existing Solid users, because I'm going to do this. And this is not a particularly happy thing for people, because I'm going to show you, because essentially you're like, why is there two functions? Right? Why is there two functions? And when I refresh the page, you're going to see hello J. And when I click it again, you're going to see hello R when it finishes. And it's because this effect separates the tracking part from the actual side effect. In a sense, this is like the dependency array. Yeah, the only reason I didn't do this is because it also passes the previous value in, so it's going to console log multiple things. I told you that there was 2 breaking changes that I foresee that would really get to people. This is one of them. React was right all along. Got it. Yeah. And I'm going to show you why in a minute. It looks a bit like ViewWatch, yeah. And we had an on helper before. It's just any VDOM library already kind of knew this. There's a very important reason here. Well, first of all, I want to show you something interesting. I don't know if you guys picked up on it. But the first interesting thing is, I'm going to put this in here just cause fallback equals loading top. Okay. Just so that people can see it. When I refresh, when I draw the page, and because it's the same async, you don't really notice a difference. But which loading symbol did we see? We saw loading, not loading top. So the first thing you're going to notice here that's kind of interesting is that create effect is above the suspense boundary, reading this async value, and it's not going to the parent suspense boundary. Why don't you do the same thing? Because we don't need to. We literally don't need to. React hasn't got rid of the dependencies on effects. To be fair, Jay Larky, I'm talking about adding the dependencies to only create effect, only it. And if you continue on, you'll see with the new design as solid, you will never need to use create effect, like very rarely. First of all, I mean, I put it out to you. What do you use create effect for in React? The funny thing is, if Felt wants to, they have two choices here. They can not throw and use something very smart with the compiler to handle this stuff, but they'll be dependent on the compiler for the behavior. Or they will opt into something that I don't think is acceptable. So my guess is they are going to use the compiler, which they depend on anyways. As I said, this is completely a runtime mechanism. Yeah, but what do you use it for? When you choose to do the right way, yes. But the thing is, we're going to make it easier and easier to do the right way because I'm going to show you the second breaking thing after here. But let me show you what the problem is here. Because the first thing is, another change that's kind of interesting here is that suspense boundaries and error boundaries generally only apply to rendering. We have create render effect that triggers it. This doesn't need to be part of it. Technically speaking, effects can handle their stuff. They can handle their own errors too, if you want to. You can make them go to an error boundary, but default wise, what I'm thinking is effects are like a mini app. They're like their own thing. So you can forget about suspense. You can forget about all of these different mechanisms and just play with signals, memo, and effect, and they will do what you expect. Create effect will wait for all the async to resolve, and then it'll run the effect as it's able to. Right? The problem with the classic effect design, I'm going to show you it. I don't know if I want to do it as a live code example, but I can show it to you as some dead code. I mean, I can show it to you live as well. Let's see if I can pull it out. But I think it's the thing. If I actually go into the next channel on the Solid Discord, we will see. I actually literally came up with an example this morning where I asked everyone a question, and I was like, "Here we go." Here's my example to the audience. What, assuming that this is async that, returns an accessor of A, an accessor of B, and C, and these are async fetches, what does this console log with the current API? Right? Basically, fetch A returns A, fetch B returns B, fetch C returns C. Does anyone know what this console logs? ABC. Undefined. Nope. Maybe. The answer is I don't know. it can return all of, I think Dev actually wrote all the possibilities in here. It can return AAB, ABC. It can return ABC. It can return AB, ABC. It can return AAB, BC. It really depends on what order these things, because if A isn't ready, it's going to throw and then nothing else logs. But if A finishes and B is ready, then or isn't ready, then it's going to throw, and then it's going to rerun it again, and then it's going to run A and B again. My point is, I don't want my effects to be unpredictable like this. Yes, because async throws. Yes, it can't be undefined. Yeah, like I don't know, right? Whereas if I went in here and wrote this, which again isn't going to make me any friends, but if I wrote this, it will log ABC exactly once. Right? Like, this is not, I don't think, like, here's the thing you have to understand with async. There's only ever 3 possible options with async, okay? Teaching moment. 1, you bail. 2, you stay in the past. 3, what's the third one? I always forget this one. Bail, stay in the past, tear. There we go. There's only 3 options, and every decision that you make around async is going to follow these 3 options. Right, approximate, yeah. Approximate, yeah. But approximate is a version of stay in the past. Bail means it's suspense. You just throw away everything. You can't show it because it's inconsistent. Stay in the past in its ideal form is like transitions. It's like you get to the source of the change and you're like, look, nothing here from this point can change. And then tear is what we get in every single app that we build when we don't account for this stuff. It's like sometimes you've got the stuff, the old stuff, and sometimes you got the new stuff, and good luck. I say that negatively, but a lot of times what people are looking for is different behaviors on major parts of their application. When you're routing, you want generally, for smoother transitions, you want a combination of staying in the past. That's what like paint holding does in the browser, for as long as it makes sense to. And then you want to bail out on the areas that are slower that you don't care about and just give loading placeholders. You don't want to tear generally on big moves. But when you're on a page updating some micro stuff, tearing is fine. Staying in the past, you have to be careful to make sure that it's responsive, that you have correct affordances. That's also fine. But you generally never want to bail. And because it's just like you're doing your thing and then just like the whole page yanks out of you. Anyone who's used suspense in Solid or React has experienced this over and over again. It's really weird. You're just doing something that's only and in the case of effects, I don't think bailing is an option. I don't think tearing is really what you want. These are things leaving the system. You should never use effects to synchronize state. So the best option you have is basically stay in the past, right? Which is requires you to know the dependencies up front, because otherwise, I don't want just random Zalgo happening when stuff leaves my system. This is kind of terrible. Right? And I'm going to convince you by the end of the stream to basically never use create effect. So, I mean, the number one reason people use effect and React is to fetch data. You have create async. So there, we've already solved the biggest one. But we're going to have more than that. You could. You could do that if you wanted these all to be wrappers. We had this debate all the time with the signals. The thing is, we use a lot of prop getters and like props. So there's another reason you want this predictable. And I think this is the most compelling. This is what sold me in the end. Do you want to know? Do you know why? Last shot at it, everyone. What does this log? I I'm even at more of a loss with this one because I don't even know what's async or not. Right. In a world where no, it doesn't need to necessarily. As I said, this isn't to do with rendering. There's interesting implications going both ways, but from my perspective, it's rendering that we need to hold on for streaming, say from SSR. It's rendering that we need that we care about in terms of whether we can move to the next page. We can hold the paint, like basically we can hold the transition, the painting, and then have other stuff in the background. Like I think the problem is people are thinking like they're going to use create effect, and they're really not. I'm basically saying that they kind of are. Like, but this is also why that other syntax isn't good because I think it's better to do this than do this. I think. Sorry. Well, it runs at the same time as it. You shouldn't be doing your side effects in it, but it does get scheduled. It does run after other stuff, but the other stuff is mostly lazy. So anyway, the thing is here is this being a function is also the first indicator that this is different than React. Your dependencies can change. Just throwing out there, and it doesn't have to be an array. It could be an object. It could be whatever you want to tell the side effect to do. Can I return props? Yes, exactly. Why not? Yeah. Why are we even doing this? This is even better. Bam. See? Win. No, you can actually you can't. You know why you can't return props? Because there's no reactive access here. No, you but you could return props, right? You have to read. You could return props. Bootstrapping procs is finally here. Oh man. The funniest thing is we're going to nitpick on this detail when it's like literally the thing that you're never going to use anyways. I knew this was going to be the point of contention that people are doing, but you understand why this is just craziness. Yeah, no, we can't do that because you need to actually read the properties. We don't know what's changed. Yep, definitely thought about this. There's lots of problems in terms of like imitating an object, like object existence. I mean, it's not a huge thing, but it still has to be a proxy, even if you're not using getter setters, especially in that case, because props can change their shape. You can have different props be defined because of spreads. So like you have to be able to ask the question, is A in props? But in order for that to be true at some point in the future, you actually have to make it so that anytime you access any prop, it returns a function, even if it exists or doesn't exist. So in general, it's just not a good idea. Yeah, I mean, it's not even an array. It's literally an accessor. You can return an array. You can do things. You literally just a tracking context and non-tracking. It's not even a dependency array. Everyone just sees it and they're like, oh, it's the dependency array. But the funniest thing is like, there's why are you using effects? I don't know if they're dramatically better. Proxies are always a performance hit, but they're also what makes it a lot more ergonomic to do deep reactive stuff. And there's some superpowers in proxies that I'll hopefully we'll get a chance to show later when we get into the mutable reactivity stuff. But what are you doing? Like what, like this is for synchronizing out of the system. I think this is the interesting. I think this is the key part. People probably have some scenario where they're picturing like instead of just being like, hey, data's updated and doing this, they're picturing like because you're not doing anything granular out of here. The more dependencies you add to this thing, the more convergence is happening. Right. I mean, to access the DOM, I mean, to do what? Like, basically, to be fair, we use effects to access the DOM internally, but like, like, because I don't want to put my DOM updates in the JSX. There you go. Right. How do you do an action based on changing prop without an effect? I don't see what. Well, the question is, what type of action again? If it involves writing to another signal, that's you shouldn't be doing that generally. So, or it should be avoidable. So again, if it's updating the DOM specifically, yes, you have a good point. You should probably create a some kind of render effect, using refs. Yeah, these are all things where you're basically getting a bunch of signals essentially and telling it to render like these side effects of the system make a ton of sense. Don't get me wrong. I'm just like I'm still very interested effectively like how big of a difference this is. Yeah, on mount is something we end up using a lot. Yeah, yeah. If you need to read from the DOM, these are the situations. It is all of those edge cases. Why not use a compiler? Okay. The same reason that Svelte 5 doesn't use a compiler. The way Svelte will use a compiler here is that they will have to introduce an explicit syntax because with a fine-grained runtime signals library, you no longer know that this is a signal. Like it could be a function, it could be anything, right? So you can't you can locally optimize, but for like async, you don't know if stuff's going to be async. The only way that I can think about doing it is if you introduce the await keyword and not actually await, because in those kind of scenarios, await has this beautiful thing from an async stance that like the consumer has to await. So you know that it gets pushed all the way up to where you are. You don't have to worry about the pull progression. So you can make assumptions off that, but you need a definite syntax to make that thing. And I don't intend to use a compiler on your JavaScript. Compiling JSX is fine. We don't actually compile the JavaScript. This is a purely runtime mechanism. If the only casualty is creative effect requiring split execution, when it's literally the edge of the whole graph, I'm going to consider this like a huge win. Like there's a whole category of things where you need to update the DOM. Definitely. And in those cases, this does act like a dependency, right? Don't get me wrong. But like from a mechanical standpoint outside of this, you're not really concerned with yourself. Don't get me wrong. I'm sure to avoid this, people will do horrendous stuff like hoist out data fetching at the component level whenever they see an await inside a create effect or something. Like, you know what I mean? Like, but then you don't get that nested fetching thing I showed you earlier very easily, unless then you start compiling the structure, like looking at the structure of the components. Like it's kind of goes down this terrible rabbit hole to solve something that is literally the least important part of the problem. No, it's literally only create effect and render effect under the hood. We don't, because everything until you get to effect is on the pure side. It's split. It's lazy. You know what I mean? So the whole chain from signals to memo to the front half of effect is all part of the same cycle. And then and it's pure, it doesn't make side effects, you can run it as many times you want, the whole kind of thing. And then all the real work happens on this side. So there's no need for anything on this side to up to here to actually have that split. You want to return the value instead of access them again, because if you access them again, then they'll throw on the wrong side. I mean, technically they won't because they'll be caught. So you could get the latest, but there is a benefit. And this is a point of contention between me and some other people. What you're guaranteed at the point of getting here and getting these values out is something that is consistent from here. If you start reading this again, and people are writing to signals and effects, it's possible to get inconsistent state. You'll get the most up to date, but you'll get inconsistent state on the back half side. Whereas here, if you're reading from here, you get a snapshot. Like the mental picture you should have for create effect is, I am leaving the system. This is for things that are not part of my, these are side effects, things that are not part of my rendering. Yeah, it only needs it because of what I've been talking about here. Nobody is able to answer me to what this console logs. It is impossible to answer this question, and it's scarier that it's impossible to answer this question even more so. Like, from a correctness standpoint, I don't even know if this is debatable. Yeah, no, we no longer need create resource. Create resource is a fancy version of create async. It has a bunch of extra stuff, but at a primitive level, create async is just an create async memo. It is the replacement for create resource. I guess that is a big change, but the thing is, create resource is like a higher level primitive. It's almost like TanStack query, without the caching. We're just lowering the level of the primitive. We'll be able to ship create async built on top of create async, or sorry, create resource on top of create async. It's like in a solid primitives or like a legacy package or something, without much effort. But the problem was create resource was too opinionated that it was hard to extend. Things like returning the undefined or falsy in the first half, and trying to get state setters in and all this stuff. We needed something simpler that was reactive tracking in order to do it, and that's why we landed at create async. The thing is, and you've seen this so far with TanStack, TanStack just imitates the behavior of the base behavior in Solid. This is the beautiful thing. They don't have to worry about all these rules around async because we handle them. Function on effects have behave different, or does only the next function run when there's not something? Yes, the next function only runs when there's not anything to await. Now, as I said, at its core, we want this blocking async because I'm going to show you a couple little quick graphs, and you can understand here. What we're going to do is we're going to color things that are async red and things that aren't async green, and then you can kind of get an idea here. And okay, so everything starts with a signal, right? So this will be green. And then I want you to consider this graph. So this is going to be an async derived value. So it's going to be red. And this is going to be an async derived value. So it's going to be red. And finally, we're going to have an effect, which honestly, it doesn't really matter. Right. It's downstream of async, so maybe that matters. But generally, what I'm going to get at here is we have signal that writes to two async derived values, and this effect reads from both of them. Now, this is called the diamond problem, right? Yellow for the traffic light. Yeah, this is called the diamond problem, and it's a classic problem in reactivity because it's always possible when you're doing this push-pull that you resolve things in a weird order. The problem with the diamond problem is in async, this is the reason why we don't fetch. If we're going to throw, we can't fetch on read, because if we're reading these, right, and let's give each node a name, A, B, C, and D. So we're in our effect D, and we're reading from B and C. If B throws before we read C, which is what's going to happen here probably, then we delay fetching C, and this causes a waterfall. So async has to be eagerly scheduled. When we know that A has changed, we need to queue B and C so that when D reads it, even if it throws early, it's still going to fetch B and C in parallel. Okay? I mean, you can do this if you want to a certain degree, but I couldn't enforce that. So if you do that, you could just put it here, but there's no way to enforce that people would do exactly this. We could leave, sorry, going back to this conversation, we could say that, I mean, there is a way to make this predictable or solvable again, right? You just got to do this. Const A1 equals A, B1 equals B, C1 equals C, beautiful. And then A1, A2, A3. Problem solved, right? Now we don't need to split it. But what I'm getting at is at the point that you have to do this, basically anyways, why don't you just do this? Do you know what I mean? Like, yeah. It seems excessive to force use effect to have an dependency when it's exclusively needed there where there are multiple effects inside create effect that depend on the effects. Right, but okay. If you don't, yeah, so it's like if you could ensure that it would only read once, then you could if there's multiple different variables, you'd have to run it like this. Like I want you to think about this for a second and realize that you're not right. You either if it's A, then the cost is basically nothing, and the second that it's more than one thing, then you know what I mean. Like it's not excessive. You're right. It could be. It's excessive if this is always a single console log. No, but I guess the argument is If this is always a single console log, then there isn't a problem. There's actually a different problem, which I haven't got into yet. There's the question of how you handle cleanup. I don't know if I want to go there right now. Create effect has always been bad. I don't know why people have thought otherwise. Create effect is not good. It has a very specific purpose, leaving the system. Yeah, I mean, it's the same problem with this. This is smart, returning the function internally, but again, you can't enforce this because people might not return the function. You know what I mean? Like they just like, oh, create effect, same syntax as before. I'm not going to do anything differently. No, it isn't. And if you look at the implementation, that is exactly what it is. Effect is the front half of the effect is basically it's extended from the computation class and then it adds an extra function at the end. So yes, that is exactly what it is. Right. But again, you're looking at it backwards. And I know this is so terrible because it's what the React team said, but like why are you accessing random functions in the side effect part? This is gonna, yeah. I mean, this is a big. And yeah, don't yeah. Returning a function is definitely possible because like the React style on cleanups. I haven't really talked about that, but um, one impact of the split is there's a difference between pure cleanups and effectful cleanups, which gets us in a zone where you want to do the React style return cleanup function on the effect side because there's no tracking context. Now, obviously, putting the tracking context together solves it, but yeah, I mean, I've seen all these proposals and gone over them. It's I don't know. Like I can show you what's on the screen here. Like it doesn't actually solve the problem, unfortunately. You either have to accept that things can just go Zalgo on you, or you need to split it, or you need to hoist it with like a compiler or something. And I think out of those options, splitting is the only reasonable one. It's so funny we get bogged down on this. You haven't even seen the cool demos yet that I'm going to show, so maybe I should just move on. They need to introduce syntax. Yeah, I mean, no one's preventing you from doing a console log on the pure side. To be fair, okay. I just wanted to show some important things related to to this because I've shown you the diamond problem. So this is why fetching has to be eager. But there's another similar problem that I want to show you, and that's what I call the flag problem. Okay, want to see the flag problem? A this is the reason this looks oh it's green. The reason this is called the reason I call this the flag problem is because so we can make this black, it doesn't really matter. Is because it's like a triangle. It's a slightly different shape. Okay. Welcome to the flag problem. The only reason that the flag problem is even a piece of conversation here is because in this case, this is an unavoidable waterfall. But this is a very big argument for why you want to throw and not tear. And by tear is only accept the last value. It's as long as it's resolved once, right? Because like this with the diamond, we can eagerly try and fetch both of these. This one will start fetching. This one will try and read B and be like, oh crap, throw. Like it won't even be able to start fetching. That's expected. But the question is like when you update it later, if you took a model where you always got the latest value, you have this interesting case where when A updates, B sees it and updates it. So when this comes here, it goes, okay, I need to refetch B. When this comes here, it sees the old value of B and then tries to fetch C with the new value of A and the old value of B. And then when it's done, it will try and refetch C again with the new value of B and the new value of A. So you fetched 2 times instead of 1 time. This is very, very, very not good from a data fetching standpoint. Throwing protects us from this async consistency problem. But if we were trying to read the previous value, we would have some problems here. So our async system throws completely internally in these scenarios. Yeah, sorry, I'm trying to follow chat. You guys are still talking about create effect. I mean, this is I mean, we could do that directly, but I mean, you've already seen it here in the stack blitz example. Upper is also accessor string, right? It's not going to be I don't think it's going to be async accessor string. So by the time we get down here, it's, you know what I mean? Async is transitive, just like normal reactivity with this model. No, not really. I mean, technically we pass in the previous argument, but because a signal accessor is not going to accept an argument anyways, it doesn't really matter. So most of the time, no. Unless you start passing it functions that optionally take arguments, like the old like observable API from Knockout. One of the many reasons why that is not a good API. Okay, so getting back to my example, you start understanding that you need to solve both the flag and the diamond problem, which leads you to basically eager fetching and throwing. But I mentioned earlier that it would be cool, and we saw this in the demo here, where see how it actually updated this expression with these two are both together independently. Well, I could go in, admittedly, and change this behavior in about one liner. And I might actually do that just to be illustrative here. I'm going to open node modules at solid.js/signals, hopefully. Oh no, it's freaking pm nested optional. This is might not be easier to get to. Node modules .pnpm/ at solid. Oh, there it is. Signals /dist. No. Oh, right. I forgot how they did this. PNPM has a very interesting format. I think we're using dev here. Okay, cool. We have dev.js for solid signals. If I go in here and find create render effect, you're going to see something. Sorry, I'm going to look at the effect class thing. You're going to see something kind of funny. In the initializer, I'm like, if this isn't a render effect, wrap it in this latest call. Otherwise, do it as normal. So if I just kind of comment out this line, and then run our example again, we're going to basically have classic. No, okay. It's not in dev. It must be in prod. Okay, we can do this again. It's like Code Sandbox has a path limit. It's like not showing me. Okay, there it is. Let's try prod. Perfect. Which one's this? Effect, render effect. Try commenting this one out. Hoping that this is not a result of something cached. Yeah, there we go. There we go. Classic React behavior. So when we click here, it goes back to fallback. So what I've done here is I've made normal effects run in this graph exactly the same way that, sorry, where's my Excel draw? Like that everything throws the way you would expect. But one of these things we were thinking of to make the experience less jarring, as I said, is this opt-in tearing ability. But the key is only the D has this latest wrapper. Latest is a helper that says, hey, it's okay. Like if there's no value, throw, suspend. And it's like .latest on create resource. But it applies to a whole expression. You can literally just say, like, for this whole function, access like 6 things, show me the latest value. And what we can do here with latest is we can essentially wrap this. So only the closest things are impacted. So if you have, if you're just reading C from here that's wrapped in latest, it doesn't change the way that this throwing behavior behaves. If you're wrapping B and C, yeah, the effect will run, when B finishes for C finishes run again, but it won't impact anything above it. So you have this ability to treat the graph consistently and just tear at the edges of rendering. Latest is a helper that essentially goes, look, I want to tear. We have in solid point 1, but now it is something that literally can wrap whole expressions, right? And the reason I'm showing this is we've made it so that, as I said, render effects essentially are latest by default, which brings me to my next example I want to show you. Yeah, well, this is an interesting question, and some people pointed this out to me before, but I think the way this works is, who's responsible for putting suspense in? Right? Who's responsible for putting suspense in? I'd argue the person who introduced the create async into the flow should be like also mindful of where their loading boundaries are. This is where the kind of question is, right? It's obviously the developer, sorry, but I mean, like there's basically no way to know if something is async, but it also the where the source comes in is where the key to this is. So like, okay, let me pull up the next, because this is all building towards this next example. This is Stack Blitz. Because the loading indicators are going to be layout. The suspense is a layout consideration, and I think this whole run once will actually make it scale better with teams, because you don't have to worry about the thing ripping out under you. Because the problem with suspense right now with the ripping out is someone adds something async and then suddenly it's just like, you know what I mean? Like, so yeah, let me see here. Solid 2 experiments. This is the one I want to open. This example was originally created by Dev for his stream, and I'm going to comment this out, and I'm going to rerun this. Okay. So this example is a little bit more complicated, but it's going to show you a bunch of stuff in play. Okay, and we're going to get into error boundaries here in a second. Okay, so first of all, let's look at what this example does. This example has an effect that logs the phrase, kind of like what we're doing before. But the idea is there is two async calls, one to like load some initial data and one to update some kind of message that we get on every frame based on a button count. And then again, we're using create memo. I'm using this again just to demonstrate the same stuff I was showing before. Now your app itself is wrapped in a giant error boundary that's just a catch-all. We're never going to really hit this unless we tell the top level to fail. Dev has included some random failure logic for this test. But the main component itself fetches some data, has a suspense boundary, renders the top level data, kind of like we did in our nested example, then has an error boundary and another suspense boundary where it outputs this message, essentially, which is just some styling on this message here. You see it here. Now, this is a pretty powerful example because, why is it being weird? Because it shows a couple things that obviously are not easy to do with a framework like React, right? First thing, obviously, is like if you fetch up top, right, and pass it down, you're going to be passing promises down, right? Like, so you actually have to change your API to message. If this is a signal, or this is, if you look here, message doesn't actually, generally doesn't need to care too much. There's this thing that I was playing with, but generally speaking, message props do not need to change in this scenario, just because you fetched at a different location. The other thing that we need to account for here is obviously we're nesting the suspenses, and yeah, I think those are actually the main two things. We'll get to the error behavior in a minute. But this has what I call tearing, where when you load first suspense boundary, second suspense boundary, that follows the normal pattern, right? Because we have nested suspense, it takes slightly longer to load the phrase. When we click a button here, though, instead of upheaving the whole phrase, we gray it out by basically giving a different affordance. And the way we did that in this example is I use this isStale helper, which is interesting because isStale is kind of like the opposite of latest. You can ask any reactive phrase here, am I stale? It could be upper phrase, it could be upper phrase or user. It doesn't really matter. You at any point in your UI, you can go like, hey, is this thing out of date? And if so, show an indicator, right? This is kind of the controversial part, right? Because if you always do fallback style, you might not need other affordances, but it's quite jarring, right? Instead of, I could turn off the render effect again like I did a moment ago, but you would suddenly see like stuff getting ripped out of your page, where this is a much more subtle thing. As we said, the suspense was kind of optional, right? We can remove this suspense if we wanted to and still have this behavior because we don't fall back to it. Suspense is only, in this case, maybe it's the wrong word for it, but it's only an initial consideration in terms of loading. Opacity is how you show stale in your old school, right? So yeah, so this is kind of like fairly straightforward, okay? There's 10 messages, loading, and as I said, you could get rid of the suspense boundary if you wanted to, and then sure enough, now the whole thing had to wait, but it still actually has the same behavior. This is what I was talking about, the scaling up concern, because suddenly you're not in a zone where like guy adds thing and suddenly whole page gets ripped. Yes, exactly. Use deferred value in React is the same as, it's very similar to our latest, essentially. So, and they use it for comparisons to do loading states. So the difference here though is, as I said, it's transitive. I'm asking is stale of upper phrase. It's not even actually even hello, or sorry, phrase. It's not even the create async. I'm actually asking it about the derived value. In fact, here, just for an example, I added is stale to the props.text, and I actually asked that the question, and it knew the answer, right? Right? So just like the async itself, the question of staleness is understood transitively to the graph. And it's interesting because I was playing around with an example. This doesn't actually trigger suspense. It's actually safeguarded. So like if you pretended that this wasn't like, it's the reason why when we do this loading initially, you can see both states, because technically speaking, you saw loading and then you saw loading. It's because this does suspend on this read, but is stale actually can ask the question without suspending itself. So this is kind of like a tool to be able to do these kind of updates. It is interesting, obviously, but I started kind of like getting into this zone. It's like if you didn't have suspense, you would have is stale or is loading kind of question anyways, right? So is this a model that could do streaming SSR without suspense? And I think the answer is actually yes, because while you couldn't stream HTML, you wouldn't have the boundaries. You could only stream the synchronous parts. You could stream the data, because what suspense does is say like, here, this is a boundary of HTML, and then we could, ship it. But if you didn't use suspense, what you could do is, if you didn't do any like things that would suspend, you could just send the synchronous HTML and then stream over the data that we know, because we do create async eagerly. We could basically stream over that data, and then the client could get that data and client render the holes. I'm not suggesting this is a good pattern. I'm just pointing out that you could have a mixture of HTML and data only streaming because of the fact that only rendering lends to the actual HTML rendering. Like, sorry, it's kind of self-evident, but you can stream data independent to the rendering, right? Is stale plus show? Yes, essentially. There's downsides of that in that it actually doesn't render, because here there is something interesting here. If we look at the console logs, what do you call it? You'll see that there is a rendering phrase counter, and there's a rendering message, rendering message. And what you're going to see here is, when I look at the console logs and clear everything out, when we load the page, we're going to see both rendering phrase, rendering message, and this is the console log phrase. When we click this, you're never going to see rendering either of them again. Now, obviously, you can see that there because it doesn't disappear, right? But like when we had suspense, like ripping it out, some people were kind of surprised by that behavior. It's understanding that there's basically these kind of live nodes in the background that can partially update even and handle the staleness, right? And I guess the thing with is stale show is you're actually unmounting it. You need also like an off-screen component. It's something that I'm thinking about, how to implement. It's a similar mechanism to suspense, but if you want to have that same idea of things off the screen and keeping them around in the same way where they only render once. Well, that's the thing. Like, again, it's if you have to follow the data flow. Do you know what I mean? Like, you're right. The child here is probably not going to do this, right? Let's face it. The child does not know. It's probably not going to do this. But it's probably more likely that you set some kind of class around the whole section, or you do something, you know what I mean? But like, who's also the one who's going to be triggering the update or defining the async? Both of those things are actually happening above, and that's probably where you're going to do most of the work, right? The one of the cool things I said about this whole scenario is essentially message didn't need to change when we went from a signal to create async. It actually did not need to change how message worked. It actually renders the same way, and it doesn't matter. Right? Like, yeah, exactly. You can also just be like, look, if this thing has the ability to show staleness, you needed today, to like if you needed to handle loading states with this component today, this would actually have an API surface for it. So like anything in Solid, props render where they're used. So if this was stale, is stale, whatever, it's still yeah, sorry. I'm gonna keep this around so I can use this. For example, we can props dot is stale, and hopefully if I want to save properly. Oh, sorry, props dot stale. What? Did I not have TypeScript on this? Whatever. My point is, where is this? This should, maybe we've hit a bug, but yeah, okay, maybe we've hit a bug, okay. But this, like, you can conceptually see that this should do that, right? If your component had the ability to show a loading state or stale state, it had that anyways. Do you know what I mean? Like, this is something that you would have to do regardless. Oh, yeah, sorry, I'm being dumb. Thank you. Yeah, there we go. Yeah, it works. Yeah. It's crazy that maybe it's my build setup where TypeScript is not complaining at me. Like I probably have it set up so that it's stripping the types rather than checking the types. You'd think that this editor would be like, don't do that. This is expecting a function, not a, because when you call it as a function, this is now a string. So then this should, yeah, something's not working correctly with the TypeScript for me right now. But anyways. Yeah. So yes, but what I'm trying to get at is this would be something that either this component is dumb and has no idea of async, in which case you wouldn't do anything for it anyways, or you're going to be handling the loading state right already in a different way. Yeah, my TS config is probably, yeah. Okay, so kind of getting the gist of the mechanism here. Like as I said, it's a commenting out a line of code that could switch us back to React's behavior, but I think this is something worth exploring, right? So let's add error handling. Let's start adding error handling. So now when we do the phrase, it's gonna 50% of the time error on us, right? And this is gonna propagate it down. So when we load, we're gonna load the page, and that one worked. But let's click. Okay. Error message, random async error. So let's look at this code here, okay? Now, there's a retry button because we added a retry button to our error boundary that resets it. What do you think happens when I click this retry button? Hopefully you're still with me, chat. Sorry, it's taking me a while to get here. Any guesses? Time to like and subscribe. Yeah, good time to like and subscribe. It follows the chain to the latest async that failed, right? It pulls back down, right? We said, right? So let's do it. Wait, what's going on? Yes. What if memos, derived values, and async values that fail outside of the current clock cycle said, okay, I'm in a failed state. I'm allowed to retry myself and try and, get my resolved thing. You don't want to cause an infinite loop, but yeah. So basically we have an error boundary down here that's reading from some derived value